done the zero factor property, which was just factor and set each piece equal to 0. We had also done the square root property, which was basically move everything over and then take the square root of both sides. And when you do that, you get plus or minus. There's 2 answers for a square root. And that's where we had stopped. But we still have completing the square. And what is the other thing? There's something else. Quadratic formula that we have to do. So, completing the square. My little catchphrase thing for it, and Virginia told me the other day she was doing her SAT tutoring, and this came up in her SAT prep, so hopefully this will help you whenever you take your SAT in the spring. But my little catchphrase for completing the square is half the middle term squared. So, number 38, x squared minus 7x plus 12 equals 0. So, a couple things about completing the square. The number in front of x squared has to be a positive 1. Okay, if it's not, then I've got to factor stuff out, or take out a greatest common factor, or I have to do a different method. So if it doesn't have a 1 in front, I can't do it. If there's a negative, I can, because I can just take out a negative, but anyways. So at this point, what we do, even if it could be factored, because sometimes you're going to have something that you actually can factor. This happens to be one that I could factor, but the instructions say I have to complete the square, so that's what we're going to do. If the instructions don't specify, you can use any method. So what we do is I move this constant term over, and so I'm going to end up with x squared minus 7x equals negative 12, and I leave a gap here because what I'm going to do is I'm going to add a box over here that I'm going to fill in. And whatever I do to one side, I have to do the other. So I'm also going to add a box over here. And then the way this works is half the middle term squared. This is my middle term, so I'm taking half of this value here. So half of that is going to be 7 over 2 squared, and the sign over here really doesn't matter because anytime we square something, it's going to end up being positive, so I don't ever put the sign with it. So when I do it like this, I usually just leave it in this form, and I'll show you why in just a second. When I write it over here, I usually will go ahead and actually perform the square, and so 7 over 2 squared would be 49 over 4. But you can do it, you can write it whatever way you prefer. It's up to you. So now the left side will allow me to have a perfect square trinomial. So the first term is squared and the second or the last term is squared. And so what I can do is we take the middle sign. So it's x minus, the reason I write it this way is whatever is being squared, that's the number that goes here. So x minus 7 over 2. And the whole thing squared. So it's just a repeated factor. Equals, you may want to go ahead and rewrite this as a common denominator. So I would multiply this by 4 over 4 to get that common denominator. And so I would end up with negative 48 over 4 plus 49 over 4. So x minus 7 over 2 squared equals 1 over 4. Now, what does this kind of look like? Something we've already done in this section.
Difference of squares.
Square root property. Okay? Because I have a term being squared is equal to something else. So I can take the square root of both sides. So this is going to be x minus 7 over 2 equals plus or minus the square root of 1/4. And what is the square root of 1/4?
1/16.
Square root, not squared. Opposite direction. 1/2. So what's going to end up happening is I'm going to have x minus 7/2 equals 1/2. Or x minus 7/2 equals negative 1/2. And so then just move stuff over. So if I add this over, x equals 8 over 2, which is 4. Or over here, if I am adding it, I'm going to get x equals, adding it, it's going to give me 6 over 2, which is going to be 3. So x equals 4 or x equals 3. So like I said, I could have factored this one from the beginning and it would have been a lot easier, but for some reason they say I had to complete the square. So if that's what they say, that's what we have to do. Any questions on that one at the moment? Okay, let me find another one. (42) x squared minus 10x plus 18 equals 0. So again, very possible that this one could be factored, but I have to complete the square. So I'm going to move this 18 over first, and I'm going to go ahead and add in my two boxes. So x squared minus 10x equals negative 18. I'm going to add a box on the left, add a box on the right. Now, it's really nice when that middle term is an even number because when I half it, it comes out to be a whole number. It's not a fraction. Obviously, that's the preferred method, but that doesn't always happen. So half of 10 is 5. So in this box, we would put 5 squared to create a perfect square trinomial on the left side. Over here on the right, 5 squared, 25. And again, I could write it either way on either side, and it's not going to change anything. I have found this to be easier, and other students have found this to be easier, so that when you go to write your perfect square trinomial, you're not thinking, especially when it's a fraction, okay, I squared this number, what was the square root of it? It's just easier if it's written this way. And then over here, since we're just going to combine them, it's easier to have it written that way. Totally up to you, though. So we take this middle sign, so this is going to be x minus 5 squared, there's our perfect square trinomial, equals, when I add these together, or subtract, whatever you want to say, I get 7. Take the square root of both sides, so I get x minus 5 equals plus or minus the square root of 7. Now, I can split this into two separate ones like I did up here, where I said x minus 7/2 equals 1/2 and x minus 7/2 equals negative 1/2. The main reason I split it was because this was something I could take the square root of. But do I know what the square root of 7 is? Right, so I can leave it. So you can write it as x equals 5 plus or minus the square root of 7 like that. Or if you want to write them as two separate things and say x equals 5 plus the square root of 7 or x equals 5 minus the square root of 7. Either way is totally fine, but if you want to save having to write extra, you can just combine them. The only time I can't combine them is when it's something like I had up here where it was a number I knew, okay? If it's I'm going to say a perfect square, then you need to actually get it out to a final answer. But if there's a square root that's going to be left, you can just write them like this. Any questions about that? Okay. They have a lot of them where there's numbers in front, so you have to do special things to get them by themselves. I am not going to have you guys do that. So I'm just going to skip over those ones. Let's see. Quadratic formula is next. And with completing the square, like I say that takes, quite a while for people to understand really what's going on and stuff like that. So you may need to do a few extra of those if you feel like you're struggling with them to really understand what's going on. All right, so what in general is the quadratic formula? Like, what's my formula for that? Yep. Have to think about it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's the quadratic formula. So again, it's possible these problems may give you something that you could factor, or you could do another method, but they want us to use the quadratic formula, so you need to make sure you do it that way. Within the quadratic formula, sometimes what's inside the radical is going to be negative, and so you're going to end up with an I as part of it. If you have that, you need to make sure you write your answer in standard form. So let's do 58. It says negative 6x squared equals 3x plus 2. So when I do this, it doesn't matter which side, but I need to get everything on one side to be able to do the quadratic formula. So I don't like dealing with negatives, so I'm going to move the 6x over. So 0 equals 6x squared plus 3x plus 2. And I would assume y'all know this, but this is A, this is B, and this is C. And whatever sign is on it goes with it. So if it's negative, the negative goes with it. If it's positive, positive goes with it. So when I plug into the formula, I'm going to have negative B, so negative 3, plus or minus the square root of B squared, so 3 squared, minus 4 times A is 6 times C is 2, all over 2 times A is 6, like that. So then I've got negative 3 plus or minus the square root of 9 minus, was that 24, 48, minus 48 over 12. So negative 3 plus or minus the square root of negative 39 over 12. So what do you notice about this?
It's all divisible by 3.
That is true. But what about in that radical? What do we see? There's a negative. So what's going to happen because of that? I'm going to take out an I. And then can 39 be broken down into anything? This may or may not be a trick question.
Yes.
It can be broken down, yes, but can I take, the ultimate question is, can I take anything out? What does 39 break into? 3 and 13. So 13 doesn't break down any farther. We obviously know 3 doesn't break down any farther. So it's going to stay as the square root of 39, but I got to take that I out. So I'm going to have negative 3 plus or minus the square root of 39 with the I on it over 12. But I need it in standard form. So it's going to be negative 3 over 12 plus or minus the square root of 39 over 12 times I. I should reduce this first part since it can reduce. So that's going to be negative 1/4 plus or minus the square root of 39 over 12 times I. So this should be your final answer. Always break it down as far as possible and simplify it as well. Are we okay with the quadratic formula since it's mainly just plugging it in and stuff? Okay. Solve the equation for the specified variable. So there's nothing that's like getting plugged in after the fact. They just tell us to solve, which is really good because a lot of times, especially if you end up taking physics or I'm sure like chemistry or anything like that, a lot of times you have to solve for a variable that's in there and then be able to continue on. So do one of those. 74 is capital E equals E squared times K over 2R, and it says to solve for the little e. So, first and foremost, I'm going to multiply by 2R. So I'm going to have 2R times the capital E equals E squared times K. I'm going to divide by K, so 2R times capital E divided by K equals E squared. And then I need to take the square root from the square root property. When I do that, I need to make sure I have the plus or minus, so little e equals plus or minus the square root of 2R capital E over K. And that would be your final for that one. Let's do 76. S equals S sub 0 plus G times T squared plus K, and it wants us to solve for T. So any idea what I need to do first to try to get T by itself?
Subtract K.
And what else?
Subtract S.
Yep, so I'm going to subtract this S sub 0 and the K. The main reason I said that is because I just want to go ahead and do both in one step, so I don't have to do it multiple times. So S minus S sub 0 minus K equals GT squared. Now what? Divide by G, so S minus S sub 0 minus K divided by G equals T squared. Then what? And what do I get when I do that? Yep. wanted to make sure you're going to pay attention to the plus or minus. Make me happy. So, plus or minus the square root of that fraction. I don't want to say it again. Any questions about those? All right, the last stuff in this section says to evaluate the discriminant for each equation and then use it to determine the number of distinct solutions and tell whether they are rational, irrational, or non-real complex numbers. Do not actually solve the equation. So in your notes, you should have had a chart that looks something like this. That said it has the solutions for quadratic equations, and it'll tell you what the discriminant is and what's going to happen. So if the discriminant is positive in a perfect square, we have two solutions and they're both rational. And that's because of the plus or minus. If it's positive and it's not a perfect square, so say like the square root of 5, there's two solutions but they're irrational. If the discriminant comes out to be 0, then there's one solution. It actually is a double solution, and it is rational. And then finally, if it's negative, then we have two solutions. They're non-real complex numbers because we'll have an I inside. So, let's see. Let's do 86 to start. I've got 8x squared equals negative 14x minus 3. So if it's not already all on one side, we need to first and foremost move everything over. So I'm going to have 8x squared plus 14x plus 3 equals 0. And I could move it the other way, but I try to get rid of the negatives if possible. So when it says to evaluate the discriminant is very specifically what's inside the square root of the quadratic equation. So that means b squared minus 4ac. Some people start trying to put the square root on it and all this other stuff. They do way too much work. All you want is what's inside. Okay, so b squared minus 4ac. So, plug in the numbers. 14 squared minus 4 times a is 8 times c is 3. Anybody know 14 squared off the top of their head? I think I know, but I'm gonna check.
Can I go back?
Yeah. Okay. 14 squared is 196. So 196 minus 12 times 8 is, what is that? 96. So this is equal to 100. So this is positive. And is 100 a perfect square? Yes, it is. So this is a perfect square. So that means that I have two, how do they say it? Real solutions. Is that what we said? Or two solutions. And they are rational. So that's the answer that it's ultimately looking for. Let's see, 88, 2x squared plus 4x plus 1 equals 0. So this one's all already on the side together, so I can just go ahead with the b squared minus 4ac. So b squared is 4 squared minus 4 times a is 2, c is 1. Nope, not Let's see, it is 1. There we go. So 4 squared is 16 minus 4 times 2 times 1 is 8. So this is equal to 8. Is this a perfect square? No. So there's 2 solutions, but these are irrational. Let's go one more. 93x squared equals 4x minus 5. So I need to move everything over. I'm just going to move the 3x squared over because I'm going to end up with a negative regardless of how I end up doing stuff and moving it. So 0 equals negative 3x squared plus 4x minus 5. And another thing to note is it doesn't matter which way I move things. Like, my final answer is going to end up being the same either way. So it's not going to make a difference. It's not going to, like, change your answer or something. So b squared, 4 squared, minus 4 times a is negative 3 times c is negative 5. So 4 squared is 16. All of these things are negative, so I'm going to still be minus 4 times 3 is 12 times 5 is 60. So this ends up being negative 44. So this is negative. So that means there are 2 non-real solutions. Or non-real, I guess I should say 2 non-real complex solutions. I'm sure that's how it's worded in the chart. Yeah, it is. 2 non-real complex solutions. All right, any questions on any of that? All right. Then problems 37, 41, um, 55, 57, 73, 89 to 91. And just another thing here, if one of these terms is missing, so let's say that this only had like those terms, so it only had the B and C terms, then wherever you have A, you just plug in a 0. Okay, if a term is missing, you just put a 0, because one of your problems may have that, and I forgot to mention that. So, but yeah, that'll be it for this section. You might be able to finish it. I don't think 1.5 had notes, but if it does, you need to have them for tomorrow. But it'll be like a worksheet thing that I give you, like what we did with, I think it was 1.2. So you'll have a worksheet, and we'll work through some, and then you'll do the other ones for homework that we don't do. So.